Alright, welcome back. This is a full course on Surds. A full course on Surds, which is meant for the GHS and SHS. But this I'm doing it particularly for the junior high school students, those who find Surds very difficult. So please pay much attention here so that you get to know one or two staffs when it comes to this very topic, which is sets. Now, when you talk of sets, we are dealing with what? Irrational numbers. Irrational numbers. And for irrational numbers, we are just dealing with the square root of prime numbers. Prime numbers we have 2, 3, 5, 7, 11, 13, 17. So these are prime numbers. So when we take the square root of them, then it means that we are dealing with sets. Now, for sets, it cannot be broken down. You cannot simplify sets, okay? Because for these sets, they are in its simplest form already. So you can't reduce them again. So we can have, let's see, 3. You can have 3 square roots of 3. Let me change my marker. 3 square roots of 3. This is a set. You can have 2 square roots of 5. It's also a set. It's also a set. Now, square root of 4 is never a set. Square root of 9 is never a set. Square root of 16 is never a set. Square root of 36 is never a set. Why? Because all these numbers here, they are rational numbers. Rational numbers, and you can reduce them. Now, square root of 4 will give us 2. Let's deal with the positive aspect of that. Square root of 9 is 3. Square root of 16 is 4. Then square root of 36 is 6. Now, square root of 4 will give us plus or minus 2, but let's deal with the positive aspect of that. Okay. Alright. So, for these are rational numbers, not irrational numbers. Why? Because it can be reduced. It can be reduced to its simplest form. So when we take square root of prime numbers, then that will give you what? A set. That will give you a set. And also sets are non-terminating, or let's say non-repeating decimals. Non-terminating or non-repeating decimals. That's for what? Sets. So we take note of that. So all these are sets. We have more examples of sets. You can get pi, which is 22 out of 7. That's 3.142. Then it continues like that. All these are sets. Now let's proceed to our next subtopic, which is what? Simplifying sets, or we can say reducing sets, or simplification of what? Of sets, or reduction form of what? Sets. How can we reduce sets to its simplest state? Okay, so let's move to our next subtopic. Alright, so simplifying sets. Simplifying sets. We want to reduce sets. Now, if you want to reduce sets, then you have to know one important thing, which is perfect square. Perfect square, or you can say square numbers. Square numbers. Now, for perfect square, we do start with 0, but there are some cases we don't consider that, because square root of 0 is 0. So there are some cases we don't consider that. So when they tell you to list perfect squares, we can start with 1. Because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 9, 4 times 4 16, 5 times 5 25, 6 times 6 36, 7 7 49, 8 8 64, 9 9 81, 10 10 100, 11 11 121, 12 12, 144, 13 13, 169. Then it continues like that. So these are perfect square, or we call them square numbers. Very, very simple. So you have to note them very well. Now, if you want to reduce surd, make sure that you have these 2 numbers. When you multiply, you get that number. So you look for 2 numbers. When you multiply those 2 numbers, it will get you back to that number. Now, that 2 numbers you are taking, make sure that one of the numbers you've taken, one of the numbers, you are taking 2 numbers, but make sure that one of the numbers is part of this family, which means it's a perfect square. So make sure that one of the numbers you've taken is a perfect square. It's a perfect square. So we have series or numerous examples here whereby I will teach you how to reduce those surds we are talking about, and make sure that one of the numbers should be part of this family, which is a perfect square. So let's dive through this properly and know how we can reduce surds. Alright, so let's see this example. When you are done with these 6 examples, you know how to reduce the surds. So, solution here. The first one, we want to reduce this surd, square root of 24. And don't forget, I said get 2 numbers. When you multiply, you get 24. One of the numbers should be a perfect square. So we have 4 times 6. 4 6 is 24. Don't forget, 4 is a perfect square. So we take that. So 4 times 6. Now, we split this because it is multiplication. We can split it so that we have square root of 4 times square root of 6. You split it open like this. Now, square root of 4 will give us 2 times square root of 6. You can't reduce it again, because when you check 2 numbers, when you multiply, you get 6. You know that one of the numbers will never give you what? A perfect square. When you take 1 times 6, 1 is a perfect square, we understand. But still, 1 times 6 is still 6. So you've gotten back to your what? To the same number again. To the same number again. So you are not reducing it. Meanwhile, you've gotten back to the same number. But here, square root of 24. It is not the same number. It's 4 times 6. 2 different numbers. I will clear here. Now, so we repeat. Because we can't reduce it, we write square root of 6. Now, 2 times square root of 6 is just 2 square root of 6. 2 square root of 6. So when you reduce square root of 24, you have what? 2 square root of 6. 2 square root of 6. Very, very simple. Very, very, very simple. So that's how we can reduce the surd. Now let's see square root of 75. Square root of 75. So square root of 75. We have 25 times 3. So as a GHS learner, you should be very smart and be fast and see the 2 numbers. When you multiply, you get 75, because you guys don't use calculator. So you should be very, very fast. You have to know your calculator, know the approach in multiplication table. Those who don't know your multiplication table, this is where you got to suffer. So please know your multiplication tables very, very well, because when it comes to this, you have to know them. Alright, now we split again. Square root of 25 times square